Hello, so we have the jam question on the board. Let me read the question and then we'll tackle the problems together. So we have this question. A circuit has an area of 0.4 meters squared and consists of 50 loops of wire. If the loops are twisted and allowed to rotate at a constant angular velocity of 10 rad per second in a uniform magnetic field of 0.4 Tesla, the amplitude of the induced voltage is A 8 volt, B 16 volt, C 20 volt, D 80 volt, JAM 2003. Now, if you look at this question is actually on the topic electromagnetic field, okay? And if you have done this topic, you know that induced electromagnetic force in a straight conductor of length L moving with a velocity v is perpendicular to a field of magnetic induction B. Okay, so this relationship can be given by this formula. Let's do this solution. It can be given by this formula. E is equal to BLV. This looks like believe, the short form of believe, but believe me, it is not believe. This is BLV. All these letters you are seeing has a name. Okay, we'll be doing that. So now for AC generator, the electromotive force for AC generator is given by for AC generator, E is given as NABW. Okay, now if it is inclined at an angle, so we have E will be equal to NABW sine theta. Now I am going to define each of these letters. Okay, I will define each of this quantity for you. Now B is the magnetic field and it is measured in Tesla. Okay, L is the length of the conductor. Okay, it is the length of the conductor is measured in what? In meters. Then V that you are saying is the velocity. Okay, the velocity is measured in meter per second square. The N is the number of tons. The number of what? Tons. Then A is the area. Okay, the area, and it is measured in meter squared. B is the magnetic what? The magnetic field. And W is the angular velocity. Okay, and what else am I to define? And then theta is the angle of inclination. Okay, now let's solve this problem. And before we solve, of course, we bring out the parameters. Okay, it's from the parameters that we'll be able to tell which of this formula we are going to be used. Is it this one? Is it this one? Is it this one? So from what the parameters, when we pick out the parameters, then we can tell which is the appropriate formula to be used. Let's do this. A circuit has an area of 0.4 meters squared. So we have A is equal to 0.4 meters squared. Okay, and consists of 50 loops. That's the number of turns. 50 loops. So we have N is equal to what? 50 of wire. Okay, we have picked this. If the loops are twisted and allowed to rotate at a constant angular velocity, so this is angular velocity. And what did I define angular velocity to be? W. So we have W is equal to what? W is equal to 10 rad per second. Yeah, rad per second. And then we have what? In a magnetic field of 0.4 Tesla. So we are given B to be what? 0.4 Tesla. I already told you that magnetic field is measured in Tesla or Weber per meter square. So we have this, right? Which is the formula that's appropriate? Is it the one I called short form of believe? No. We don't have length. We can use this. We don't have velocity, so we can use this formula. So let's check out the second one. Do we have N, the number of tons? Yes, we have it. We have A, yes, we do. Do we have B? Yes, we do have B. And we have W. So this is the one we are going to be using. We are going to be applying this formula. So we have E is equal to what? NABW. So E is equal to, now let's substitute everything we have picked from the question given. So we have N is equal to what? 50 times A is what? 0.4 meters squared, right? So we have 0.4 times B. B is what? 0.4. And then we have times, maybe I should just wipe, okay, times what? W. Can W enter there? W is 10. Okay, 3. So times 10. E is equal to. So all at this junction, all you should do is what? Punch your calculator. Okay, you punch calculator. You don't need to suffer yourself. This is jam. You punch your calculator. Okay, even if it is WAEC, just your correct substitution. You don't need to show your working. Correct substitution into a mark, and then just punch calculator and get your final answer. That's all. Okay, so if you punch your calculator, this times this times this times this, it will give you 80. Okay, it will give you 80. This is the answer. 80. Of course, you know EMF is measured in volt, right? And so let's check our options. We have 8 volts. No, it's not 8 volts. 16 volts. No. 20 volts. No. And yes, 80 volts. This is the correct answer. So we have D to be the correct answer. All right, I'm still Bukola Joseph. I hope you enjoyed today's problem solving. Thank you for your time. Bye.